In this video, we're going to look at solving a system of linear equations by graphing, and we're not going to use technology. We're going to graph these by hand. And so all of these problems that we're looking at in this video are going to be written in slope-intercept form. And so if I'm given a system of equations and they're written in slope-intercept form, my solution to linear equations is going to be the points of intersection. So I'm going to start by graphing the first question here on the left-hand side. We have a y-intercept of -6, a slope of 3, so that means I go up 3, right 1 for every one dot that I have. And so we would do that, and we would fill this all the way in until eventually we ran out of room. And then we would connect our dots with a line. So we have our line here, and now we're going to do the same thing for the second equation. So we have a y-intercept of 8. We have a slope of -1/2, so that's down 1, right 2, down 1, right 2, down 1, right 2. And then we would keep going on, and then we would connect all of our dots. And we would see where the solution would be to our system of inequalities. And our solution is going to be where the lines cross at. So the lines cross at the coordinate 4, 6. So that's the coordinate that satisfies both equations, which would be the answer to my system. All right, new problem here. So we're going to solve this system by graphing. So I'm going to graph the equation y is equal to -x plus 5. I have a y-intercept of 5 and a slope of -1. So I go down 1, right 1. And I keep doing that until I run out of room. All right, so we'd connect all of our points there. And we'd have this nice diagonal line. And we'd come on over to this side. All right, so that's our first one. And now we would graph our second equation, and we're looking to see where the lines touch or where the lines cross at. So we got a y-intercept of -5, a slope of 3/2, so up 3, right 2, up 3, right 2. And then we would connect those dots with a line that passes through there. Okay, and that line would go on forever in both directions. Now remember, what we're looking for, our answer to our system, is where the lines cross at. Well, they cross right there at that point, which at that point has a x value coordinate of 4 and a y value coordinate of 1. There's our answer. Now we have a system of linear expressions here, and we're going to graph them as well, and we're going to look to see if we can't determine where our possible answers would be. So this first equation we're given has a y-intercept of -7. It has a slope of -2. So that means I go down 2, right 1, down 2, right 1, and I keep going until I run out of room. Well, I'm going to need to go the other direction, so I'm going to go up 2 and left, up 2 and left, and I'm going to connect these dots with a solid line. It's a solid line because of that inequality symbol. And so I go connect those dots with a solid line, go all the way through those points, and we have that line there. Now I got to figure out, well, how do you shade? Well, y is on the smaller side of the inequality, so that means I got to shade below the line. So everywhere in this region, I'm just going to do lines here instead of coloring the whole thing in. But anywhere in this marked up region would be a possible solution to that first inequality. Now, we have a second inequality that the points must satisfy. So I'm going to look at the line, or the inequality expression. Y must be greater than x plus 2. So this one, we have a y-intercept of 2. We have a slope of 1. So up 1, right 1. And I need to go the other direction, so I need to go down and left. And I'm looking for, and it gets a little harder to plot your points when you get in the shaded part. All right, so I have to have a dashed line here because that inequality sign is not inclusive. So I'm dashed. So any point on this line cannot be included in my solution set. And we need to graph this. So I finished graphing with my shaded. The open part of the inequalities towards the y. So that means we shade on top of the line. So all points on top of that dashed orange line are solutions to the orange equation. Now, what I am looking for are answers that fall inside of both areas that are shaded by both. So it's all of this region over here would be my set of expressions that are shaded by both. So any point that lies inside of this commonly shaded area would be an answer, any coordinate. So if I had to pick a coordinate, I'd pick a coordinate in what I shaded as red to be a solution. All right, here's another example here. We have two inequality equations we want to graph and see the set of possible solutions by looking at the common shaded area. So we have y is less than negative 1/2 x plus 1. We have a y-intercept of 1. We have a slope of negative 1/2, so that means from that point you go down 1, right 2, down 1, right 2, and you're going to keep doing that until you get enough points to make your line. Now, that inequality symbol does not have a line up under it, so what that means is that we have to have a dashed line. So we're dashed line in here. So any point that falls on this line does not satisfy that inequality because it has to be less than the line. Now looking at the inequality symbol, since y is on the smaller side of the inequality symbol, we have to shade underneath the line. So any point, any coordinate that falls under this line here would satisfy that expression. Now we also have to satisfy a second expression, which is y is less than or equal to x minus 2. So that one has a y-intercept of negative 2. It has a slope of 1. And so I'm going to make all my dots. Up 1, right 1, or down and left. And it has a line up under the inequality sign, so it's a solid line we got to draw through here. So I'm going to make a solid line. And again, the small part of the inequality sign is towards the y, so I would have to shade underneath the line here. So everywhere underneath that blue line would satisfy that second equation. Now for a system, we have to satisfy both equations, so I'm looking for the commonly shaded parts. So the commonly shaded region here is going to be all of this here in purple. And also, it would include, check this out, it's going to include this section of that line there, because that part of that blue line is technically shaded, and I include that whole piece. So all of that in purple would represent coordinates that would satisfy that inequality.